Yeah. I have been asked many a times a question whether a 13 rod abacus is good, or a 17 rod abacus is good, or a 21 rod abacus is good. So let me put forth the point over here. When it comes to addition subtraction, right, and we are training somebody or students on doing addition subtraction on abacus and then referring it to the imaging and visualization of the tool, the practical applicability on a 13 rod abacus, if you are following a center rod concept, you can have 1 2 3 4 5 6 7 digit long number on a 13 rod abacus, and on a 17 rod it is 1 2 3 4 5 6 7 8 9. So practically speaking, a 7 rod is also a very large number, and a 9 rod number is also a very large number. But then these are two extra rods you get on the 17 rod. But then when it comes to teaching students in a training environment for all the applications for a practical size of a number, then 7 rod is also a very wonderful size of learning abacus. And if somebody wants to move ahead, then they can later on upgrade to a bigger size. Could be a 17, could be a 21, could be a 27, or could be any size for that matter. Now let's talk about multiplication. Now, as we know that we need to create a gap of at least 2 rods between the multiplicand and the multiplier. So you can have 1 2 3 digit numbers and a 2 digit number being a multiplicand or a multiplier, and whereas on 17 rod abacus you can have 1 2 3 4 and a 3 digit number, or vice versa. You can have 3 digits here and 2 digits here, or you can have 4 digits here and a 3 digits here. And if you can manage the gap or the differentiation between the two numbers, then you can, with a single rod, then yes, you can have 3 digits on both the places. So which is possible, very much possible on a 13 rod abacus as well. Now when it comes to division, you can change the perspective, because division comes quite at a later stage. And if you can change the perspective of the unit rod to a learner who has learned addition, subtraction, multiplication, and then he's coming on to the division, if you change the perspective of the unit rod from this place dot to this place dot, then a 13 rod abacus can also deal with good number of digits for dividing a number, keeping in line the rule, that is, you have to maintain a gap of 4 digits, 4 rods or 3 rods on abacus for differentiating the dividend and the divisor. So if you maintain a distance of 3 digits between the two numbers, you can divide a 4 digit with a 3 digit, or you can divide a 3 digit with a 4 digit. And when it comes to a 17 rod abacus, if you don't change the perspective, then surprisingly the size is smaller. So if you have to use division on a 17 rod abacus, even for a higher difficulty level, at 17 rod abacus as well, you have to you have to change the perspective of the unit rod to the right, so that you can find the answer in middle, and you can divide a number, or you can divide a 4 digit with a 4 digit, or a 5 digit with a 3 digit. So this is how it is. But then if you see at this situation, and if you can, because the rule is to maintain a difference of 3 or 4 rods, so you can use even a 13 rod abacus. So what I mean to say over here is, a size of 13 rod or a 17 rod will not make much of a practical difference when it comes to training students on the basic operations of mental arithmetic, adding, subtracting, multiplying, dividing, finding out fractions, percentages, LCM, HCF, or square root for that matter, right? So a 13 rod abacus is also very much suitable, and a 17 rod abacus is also very much suitable. So if you have a budget constraint and you want to market your product with the right kind of a pricing, you can even use a 13 rod abacus. And if you want to use a 17 rod tool, you can obviously use a 17 rod tool. It is not a very big issue when it comes for the trainers, when it comes to teaching students. Yeah, thank you. I hope this would have helped. Thank you.